Poor management of hazardous waste can lead to environmental pollution, injuries, and adverse health risks. Children's exposure to hazardous waste may cause serious acute and chronic health problems due to their higher vulnerability to the toxic effects of chemicals. This project examines an incident of illegal chemical dumping in Pasir Gudang, Malaysia. On 6 March 2019, tons of hazardous waste were illegally disposed into Kim Kim River, Pasir Gudang, Malaysia. They were identified as benzene, acrolein, acrylonitrile, hydrogen chloride, methane, toluene, xylene, ethylbenzene, and D-limonene. As a result, 975 students in the vicinity developed signs and symptoms of respiratory disease due to the chemical poisoning. Residents of Pasir Gudang are prone to environmental pollution due to its rapid development and industrialization. Prior to the incident of illegal toxic waste in 2019, the environment in Pasir Gudang specifically and areas around the Johor Straits in general were exposed to pollutants resulting from anthropogenic activities. The 15 km long Kim Kim River, running from the Masai sub-district and flowing southward in Pasir Gudang into the Straits of Johor, is considered one of the most polluted rivers in Johor Bahru. Now, let's talk about toxicokinetics of chemical involved in this. Among the most toxic chemicals in the incident of Kim Kim River are acrolein and acrylonitrile. Both acrolein and acrylonitrile vapor are heavier than air, hence, inhalation of acrolein and acrylonitrile may result in respiratory distress, especially in enclosed, poorly ventilated, or low-lying areas. Acrolein is relatively unstable in the atmosphere and its atmospheric half-life is estimated to be about 15 to 20 hours. In the troposphere, acrolein reacts with hydroxyl radicals and ozone that then produces carbon monoxide and formaldehyde. High exposure to carbon monoxide and formaldehyde are also harmful and can cause negative health effects. The level of airborne concentration of formaldehyde that may cause irreversible or serious long-lasting adverse health effects is 14 parts per million within 10 to 30 minutes of exposure, which is 30 to 140 times more potent than the concentration of acrolein. Like acrolein, air-emitted acrylonitrile reacts mainly in the troposphere with photochemically produced hydroxyl radicals. Its atmospheric half-life is estimated to be about 5 to 50 hours. The reaction of acrylonitrile with hydroxyl radicals forms formaldehyde and, to a lesser degree, formylcyanide that would react with water to produce hydrogen cyanide, which is unlikely to cause health effects in a low concentration. Epidemiological studies on the long-term effects due to inhalation of acrolein and acrylamide have not been identified. However, animal and in vitro human airway tissue model studies showing exposure to acrolein and acrylamide were linked to oxidative stress and inflammation response, which led to increased mucus secretions, edema of the bronchial wall, bronchoconstriction, and tissue damage. Hence, this chemical reaction indicated the possibility of children suffering from respiratory symptoms due to exposure to high concentrations of toxic chemicals from the illegal waste dumping site in the Kim Kim River incident. Next I will explain about toxicokinetics of benzene.
Benzene is lipid-soluble and highly volatile at room temperature. As such, benzene readily crosses the alveolar membranes and is taken up by circulating blood and pulmonary vessels. Benzene is rapidly absorbed through the lungs. Approximately 50% of the benzene inhaled in the air is absorbed. Benzene can also be readily absorbed from the gastrointestinal tract. Over 90% of ingested benzene is absorbed through the gastrointestinal tract. Benzene is poorly absorbed dermally. Absorbed benzene is rapidly distributed throughout the body and tends to accumulate in fatty tissues. Circulating benzene is preferentially taken up by lipid-rich tissues such as adipose and nervous tissue. Benzene has also been detected in the bone marrow, liver, kidneys, lungs, and spleen. The liver serves an important function in benzene metabolism, which results in the production of several reactive metabolites. These metabolic products are subsequently conjugated with inorganic sulfate and glucuronic acid before being excreted in the urine. A small fraction of the catechol derived from benzene metabolism is oxidized to hydroxyhydroquinol or transformed to muconic acids. Exposure to benzene has been associated with increased risk of respiratory symptoms in children, including wheezing and shortness of breath. At low exposure levels, benzene is rapidly metabolized and excreted predominantly as conjugated urinary metabolites. At higher exposure levels, metabolic pathways appear to become saturated, and a large portion of an absorbed dose of benzene is excreted as a parent compound in exhaled air.
Now, we move on to carcinogenesis part. We start with acrolein first. For adverse effect of acrolein is severely irritating to skin, eyes, and mucous membranes. Inhalation of acrolein may result in respiratory distress and delayed pulmonary edema. Contact with the skin or eyes produces irritation and lacrimation, and can result in chemical burns. The mechanism by which acrolein produces toxic symptoms is not known, but the compound is highly reactive. No information was found as to whether the health effects of acrolein in children are different than in adults. Exposure to acrolein produces severe respiratory problems, and individuals with pre-existing breathing difficulties or skin disease may be more susceptible to its effects. Conditions which increase risk of exposure include physical and mechanical processes, heating, pouring, spraying, spills and evaporation from large surface areas such as open containers, and confined space exposures, working inside vats, reactors, boilers, small rooms, etc. Next, let's talk about acrylonitrile carcinogenesis. May reasonably be anticipated to be a carcinogen. Long-term exposure to acrylonitrile in air or water may increase your chances of getting cancer. Humans who are repeatedly exposed to acrylonitrile in the workplace for many years may have a higher than average chance of developing lung cancer, although this is not clearly established. Can cause cancer of the central nervous system, microglioma or glioma, and enzymal gland, carcinoma, and benign tumors of the forestomach, squamous cell papilloma or acanthoma, in both sexes. If the exposure is for a long enough period of time, acrylonitrile can cause death. Exposure to large amounts of acrylonitrile for a short period of time, as might occur in the case of an industrial accident, results mainly in effects on the nervous system. At higher concentrations of acrylonitrile there may be temporary damage to red blood cells in the liver. Direct contact of your skin with acrylonitrile will damage the skin so that it may blister and peel. Exposure of the skin to high concentrations of acrylonitrile in the air may irritate the skin and cause it to turn red. The redness may last for several days. For risk exposure it include workers involved in the manufacturing of acrylic fiber and plastics. Employees who work in the coatings and adhesive industries. Workers in the manufacture of other chemicals like adiponitrile. Factory workers producing nitrile rubber products. Lastly, I will explain about carcinogenesis of benzene. Studies show benzene exposure can increase the risk of certain cancers by as much as 40%. Benzene can increase risk of multiple myeloma, while others indicate a dose-related increase for total lymphatic and hematopoietic neoplasms. People who breathe in high levels of benzene may develop the following signs and symptoms within minutes to several hours: drowsiness, dizziness, rapid or irregular heartbeat, headaches, tremors, confusion, unconsciousness, death, at very high levels. Among smokers, 90% of benzene exposures come from smoking. Benzene may also be found in glues, adhesives, cleaning products, and paint strippers. Outdoor air contains low levels of benzene from second-hand tobacco smoke, gasoline fumes, motor vehicle exhaust, and industrial emissions.
12 ways to reduce polluted runoff.
Properly dispose of hazardous household items. Oils, antifreeze, paint, solvents, cleaners, preservatives, and prescription drugs should not be poured down a household or storm drain. Check with your county waste management service to find out what hazardous materials they accept. Reduce or eliminate the use of fertilizers and chemical herbicides and pesticides. Learn to live with a dandelion or two. Lawn fertilizers and chemicals are a big source of nitrogen and phosphorus pollution and toxic runoff. Make an appointment to service your septic system. Landscape with native plants. Eliminate bare spots in your yard. Make a rain garden. If you live on the water, build a living shoreline. Resurface with permeable pavers. Participate in a local training or certification program. Plant a tree. Become an informed voter. Install a rain barrel, or two. Placed at the base of a downspout, a typical rain barrel can hold 55 to 75 gallons of stormwater runoff from a rooftop, reducing flooding and erosion. They can be bought from garden supply centers or easily built. Learn how to build and install your own rain barrel. Conclusion: all of the chemicals involved in the Pasir Gudang incident were mainly generated from industrial activity. Most of the chemicals have a characteristic that can produce toxic gas in the air through reaction with other chemical substances or rays. This causes the chemical potential to vaporize and produce fume or gases that may cause respiratory illness to the victims. This is consistent with the fact that the main route of exposure for a chemical is from inhalation. The toxic gases were positively identified as acrolein, acrylonitrile, methylmercaptan and benzene. The symptoms experienced by the schoolchildren of vomiting, nausea, dizziness, shortness of breath, coughing, sore throat and muscular cramps, were consistent with the adverse effects of inhaling these gases. In the short term, better methods of assessing adverse health effects of simultaneous exposure to multiple chemicals should be developed, such as chemical fingerprint.